Hi Profs, we are Team 16 and this is our final presentation. To jump right into it, we'll first start by sharing the problem statement of our project, then the statistics portion followed by the MSO portion. For our project, we managed to work with Car Club, a car sharing operator in Singapore. The problem we have been helping them to tackle is the question of how we can help them optimize the maintenance scheduling of their cars while ensuring that demand for car rentals is met. These are the crystallized objectives. And now, for the statistics component, we did data processing, visualizing, as well as regression and ANOVA tests. The first thing we did was find out the average number of hours each day cars were being used for. Next, we also wanted to find out if there was a best time that Car Club could send cars for maintenance at. Please note that these questions will be answered through later portions of our presentation, even in parts of our MSO component.
Now, before I continue the presentation, I'll be referring to car booking hours as demand interchangeably. Using the data mentioned above, we are able to visualize the demand through the following graphs. These graphs are actually plotted using 3 different types of categorization, namely region, days of the week, and time period. Zooming in on the different graphs, the region graph actually shows us of 5 different areas where Car Club stationed their cars, which actually has a higher demand. The significance of this is further proof in the ANOVA analysis. The days of the week graph shows us the demand trends and how it differs across different days of the week. Lastly, our time period graph shows us the number of cars used within each hour of the day. This demonstrates where the peak periods are within the day itself and when a car should be sent for maintenance. Combining these 3 factors, we could possibly obtain more specific results, such as the number of cars used within each hour of the day for a very specific region and a very specific day of the week. Example hypothesis will be as shown on the slides. Lastly, we actually plotted multiple graphs to explore different relationships that we did not show. Our findings involved that the weekend demands were actually approximately normally distributed. Moving on to the regression, the objective of our regression is actually to find the relationship between demand for cars and days of the week across the time period. The dependent variable we use is demand, whereas our 2 independent variables is the days from 1st April 2019 and the days of the week. We involve dummy variables to represent the categorical variables used, and we involve interaction terms too. From this regression, we conclude that the demand across time period does not change much, with the exception for weekends where it shows a negative relationship. Demand does change across days significantly. Now I'll pass on the time to Sabari to talk about the ANOVA analysis.
Thank you, Danny. The team decided to test whether demand for cars are consistent in the data set given. We identified 4 factors such as region, day, weekend, and weekday. We did 2 one-way ANOVA tests and 2 two-way ANOVA tests. Unfortunately, all tests failed. One of the tests that we have done is shown on the slides, a 2-way ANOVA test. As you can see, there's no interaction between regions and days, thus further supplementing the regression analysis did earlier.
Moving on to the MSO portion of our project, we have 3 main parts to cover. Firstly, we will be using the reverse QR model as suggested by Prof. Shruti. Next, we will explain how we find our QR parameters. Lastly, we will be moving on to explain our CTMC modeling. We first identify to use the QR model as the inter-arrival times of demand are independent and identically distributed. There is a unique cost, which is the maintenance cost associated with placing an order, which is sending a car for maintenance service. Additionally, Car Club has mentioned to us to take the replenishment lead time as 1 day. We will be using the reverse QR model in our case. This is because there is a fixed inventory of cars in Car Club's fleet. So, instead of replenishing inventory when the inventory position falls below R, we will send Q cars for maintenance when the inventory position is above R. Q corresponds to the number of cars that will be sent for maintenance, and R corresponds to the point whereby cars should no longer be sent for maintenance in order to keep the cars to meet customer demand. The trade-offs that we have identified is holding inventory versus having backorder. The costs we have identified are the profits lost, which is $14 per car, the breakdown cost, which is $2,000 per event, and the order cost for maintenance of 1 car to be $80 as mentioned by Car Club. We also made a few assumptions to fit our model. We would use only the data whereby the car is borrowed for less than a day. We assume that when a car is not sent for maintenance, it is off the booking page and cannot be booked by customers anymore. And when a car is sent for maintenance, the car cannot be booked for a day. We also assume that a car would not reach the 10,000 kilometers mileage, hence only taking the 6 months criteria. Lastly, the maintenance cost, holding cost, and stockout cost are constant in calculating the parameters. Hani will talk more about the QR model parameters now.
Before we can calculate the parameters of the QR model, we first explore the demand. Plotting a histogram of daily booking frequency shows that demand seems to arrive according to a Poisson process distribution with parameter mu. To calculate mu, we use the inter-arrival time of booking, denoted as x, which will follow an exponential distribution, also with parameter mu. And using statistical concept of method of moments, or MME, we approximate the demand for each region. Since mu is large for all regions, we can approximate Poisson distribution to a normal distribution, where mean demand is mu and standard deviation of square root of mu. We use this to calculate the reorder point.
Using the aggregate values derived from the data in previous slides, we can model the process into a CTMC. Then, using average cost analysis, we can estimate a Q value, which will optimally produce Car Club's desired utilization rate of around 40%.
In conclusion, we've been able to help Car Club optimize their maintenance period by figuring out for them the best days to send their cars for maintenance, as well as the best timings to do so. We've also been able to help them to optimize the safety stock level in terms of determining the number of cars to be sent for maintenance at one go, as well as the reorder point. With that, this goes to show the power of stats and MSO. Win! With all of that said, we'd like to thank you for your time and attention. Thank you very much.